Now we're going to look at some more division properties. These are really important ones that you kind of need to know for all division problems. So it starts off pretty simple. If you take a number a and divide it by 1, you get a. I mean, this isn't saying anything too crazy. Another way to write this would be a divided by 1 is equal to a, right? If you divide something into one group, you get the original something back, right? Like 5 divided by 1 is 5. So if you have 0 divided by a, you would get 0 for the same reason, right? So if you plug in a 0, it's fine. So 0 divided by a is 0. That's fine as long as the top is 0. But a divided by 0 is undefined. This is something we cannot have. So if you take a number and divide it into 0 groups, how do you divide something into 0 groups? Like, that doesn't even make sense. So you cannot have a 0 on the bottom of your fraction. You can't divide by 0. You can divide into 0, you just can't divide by 0. So 12 divided by 0 means to divide 12 into 0 groups. How are you supposed to do that? That's why it's undefined. 0 divided by 0, also undefined. Anytime you have 0 in the denominator, it's undefined. 0 divided by 12, though, that means to divide 0 into 12 groups. And if you have nothing, like if you have no money and you're going to split it up among your 12 friends, well, they also get no money, right? Nobody gets anything. 0 divided into 12 groups is 0. So just again to summarize, same idea here. Undefined if you have a 0 in the bottom. 0 over 0. See, again, that's a 0 in the denominator. That's undefined. 0 on the top is okay, though. This one's okay to have. 0 divided by a number is 0. You just can't have the zeros underneath as your divisor. They also, in the book, wanted to remind you that multiplication and division, those are inverse properties, or inverse operations, I guess I should say. So you start off learning about addition and subtraction. We know those are inverses because they undo each other. Well, if you repeatedly add, you get multiplication. And if you repeatedly subtract, you get division. And so it turns out that multiplication and division are also inverse operations because they come directly from addition and subtraction. So let's look at some properties. We found out that some of these properties didn't work with subtraction. So let's find out if they work with division. So the commutative property, remember, to commute means to move. So if we want to move the numbers, does that work in division? Can you switch the numbers and get the same answer? So I just came up with a quick example here. 10 divided by 5 versus 5 divided by 10. Are they the same? Well, 10 divided by 5, that turns out to be 2. If you do 5 divided by 10, we haven't even gotten to this part yet because we're really just dealing with whole numbers. But that's not a whole number. Actually, 5 divided by 10 turns out to be a half. And those are not the same. So does it hold? No, you can't use the commutative property with division. Why? Because the order matters. Who is being divided by who matters in division. The associative property also does not hold for division. Why? Well, it probably has something to do with ordering. So let's see. The associative property is just who's associated with who. This is the parenthesis one. So I have 100 divided by 10 divided by 2. 100 divided by 10 divided by 2. So you see how 100, 10, 2, the order's the same. But you have to do the parentheses first. So over here on the left side, I would have to do 100 divided by 10, and I would get 10. And 10 divided by 2 is 5. So on the left side, I get 5. On the right side, I have to do the parentheses first. 10 divided by 2 is 5. And 100 divided by 5 is 20. So see, the order matters. So if you do this parenthesis group before the other parenthesis group and you don't switch the order of the numbers, you're not going to get the same thing. So are those equal? No, those aren't equal. So commutative property, associative property, it all falls apart when we get to division. Subtraction and division, those are our problem operations. The properties don't all work. And whole numbers are also not closed. Remember, closed means if you take any two numbers in a set and divide, you should get a whole number that's also in the set. So it says, is this set closed? Now this happens to be whole numbers, they're just even numbers. Is that set closed for division? Well, you might say, take any two numbers like 8 divided by 4, that's 2. Is 2 in the set? Yeah. How about 6 divided by 2? 6 divided by 2. That's 3. Is 3 in the set? No. Okay, well that breaks it right there. Also, if we were to try to do 2 divided by 8, that's going to be 2/8. That's a fraction. That's not inside the set. If we tried to do any other even number like 12 divided by 2, that's 6. That one works in the set. So you have to stumble upon one that doesn't work. And sometimes that's kind of hard to do. Our brains kind of look for the ones that do work. But this one is definitely not closed. And again, it all boils down to order. 8 divided by 4 and 4 divided by 8, not the same thing. And so you don't necessarily get a closed set.